Hello, let's continue making Gaussian goblins in Unity, and today I'll be actually refactoring the state machine code to make it easier to implement new states as we go. Alright, so first I'll start by the state base right here. So as you can see right here on the state base, uh, still a scriptable object, but now I got a read-only collection instead of array right here. Uh, and I also got is initialized state. It will make sense later, uh, but basically we can still use this state base for different states, so we don't want to initialize this multiple times. That's why I got this field, a bool field call, saying if we initialize it or not. Uh, Next, I got this set state transitions, uh, just checking if it's not no, this state transition right here. And then we set the state transition, very straightforward. And here I got this initialize state that just initialize and set up the state, passing this entity components reference that I will show later. And the and here it's the same thing. All right, it's all the same thing right here. Okay, so next, I forgot to say that I also got this state machine parameters. Uh, I will create this later, but for now, let's just skip this error. Okay. So next, we got the state machine base. So here on the state machine base, it will not be more state machine base, but it will be a state machine and a sealed class right here, because we will not inherit anymore from this class and use as a base for the player state machine. Instead, uh, we just skip this for all the entities that need to be a state machine, whether it's player, enemy, whatever. Okay, that's why we also make this sealed. Next, we got StateMachineStates that I will show later, and the StateMachine parameters. Basically, the StateMachineStates is where we set all the states and then we just instantiate them at runtime on awake right here. And then we just initialize them and then we just keep each entity with its own state machine. That's why we use this state machine states. Uh, then we still reset the state machine like we're doing right here. Let's go to this code, but we get the first and the base state. I will show the code later, but it's basically the same thing. The update, click the update, fix it. It's all the same thing. We're still checking for transitions, but now it's just the main class for everything. And this entity components reference, I guess it will be the last thing that I'll show, right? So the next one is the StateMachineStates right here. So previously the StateMachineStates uh, was a directly reference to the scriptable objects right here on the state base. But now all we need, all we are doing is creating an instance for each state. And here we got the state definition that I need to show before showing this whole class. So the state definition is basically a class that we use to get the base state and the state transitions to initialize through the inspector. And this validate is just for um, to see more clearly on the inspector. I'll also show that later. But let me just copy the state machine code and paste right here. Let me rename this to the state machine and paste. It still got some errors, but okay. So right here on the state machine states, we got a list of states definition of this class right here. And we also got a linked list of states definition that we are going to set down here. And the dictionary, this is very important, of the cached object instance. The reason why we are using this dictionary, the type and an object, let's say that you got your idle state and and you also and in your jump state you also got your idle and your movement. You can also transition to the idle stage. Instead of creating one copy for each state, you actually just get the single instance of the whole state machine states. That's why we got the type and then the object instance right here. And we also instantiate the state machine states right here on the state machine, right over here. Alright, so on awake, we just clear this read-only dictionary, and then for each state definition, we are going to instantiate all the states. So I got this hash set right here because it can't add um, duplicated items. That's why I'm using this hash set just to make sure that nothing will be duplicated on the state machine. And then the states transitions, that is right here. Let me show this class first. The state transitions got the StateBase, the transitions that needs to go to the transition state, and then if the conditions needs to match, like the same thing that we were doing before, but now it's in a separate class. Go back here, and then we just get a new because we are setting through the constructor, and we are getting the values from the states definition that we set the inspector. So let's go to these methods. So the get transition state from state transition, we basically are looping on the state definition that we set right here on the inspector, and then we just instantiate the inspector, the state, if the dictionary does not contain the key. If it does not contain, we instantiate the object, else we just get the object that are currently on the dictionary and set as a transition state. Alright, and we do the same thing here on the transitions. For each transition condition base, let me show the class transition condition base. Basically got initialized because it will be the same thing. We don't want to initialize this transition multiple times. That's why I'm using this field. And here on the initialize condition, I'm just setting up the condition in a abstracted method. Alright, let me go back here, and then we just add to the transition, and if it does not contain the, of course, if it does not contain the state, the transition, we create a new instance, else we just got the instance that are currently on the dictionary. Right, and after all this, we do later, just add to the last on the linked list, the last on the state definition, we have the new state definition that we set right here. All right. So that's all for the state machine states. It's basically creating a instance for each object, and that's all we do. So let me just paste this code. I'll do the same thing here on the state definition. I guess yeah, I don't have this class right here, so I need to create a new one. Add new class. It will be state definition. Right, and then also got the state transition that we need to set. Right over here. And this field right here just say that this can be a list, a linked list, a hash set, whatever. But later we just convert this to list using a link. Alright. And also the transition condition base. Let me just paste here. Alright. And as you can see, we are creating a abstract state machine, so we won't need anymore the player specialized player state machine. Okay, so I guess the state transitions is already go. No, it's the state machine parameters. So basically this state machine parameters base, uh, as the name goes, it's a basic class for all the state machine parameters. This is, I guess this is for what are, and this is the only thing that we need to convert to the player, create a specialized version of the state machine, is the state machine parameters, because every entity will have its own parameters. Like the player will have the job height, and for example, the enemies will have damage, you know. So that's it for the state machine parameters base. Now, as you can see, I can't inherit from the state machine because it's sealed. So let me just remove the player state machine. The player state base, it will continue because we need to convert the player state machine parameters. But now we can just, instead of create a new virtual, we can just override this. So let me just paste this code. It's the same thing, but it's just checking if it is initialized or not. And I'm just okay. And here on the player state machine, I need to inherit from the okay. And I'll also keep this, but instead of being a player component, it will be entity. And let's go back to Unity. The state machine parameter is okay. The player state base we also need to get, but we don't need the player state machine transitions anymore. Move. and also the condition. All right, so let's just remove this player state transition. And also remove this and this as well. And I'll just create a new StateMachineStates. For now, let's just keep there alone. All right. Because we need to fix these errors so that the script compile. All right. So let's create this entity components reference. So I'll create right over here on a scripts folder or on the global, but for now let's just keep right here. Entity components reference. Let me open this. So the script that I wrote to make abstract reference for each entity that you have in your game is very simple. We just got a read-only dictionary, entity cached components, the same thing like on the cached states objects that we did. But here, when you get the entity component, we just check if it does not contain, then we get the components in children because it also gets on the same game object. That's why we check for in children. Basically, it traverses all the game object and childs. And here we also just get the dictionary here on the key of the component type that we cast right here, and set the component that we get right here, and then we just return the component that if does not contain else contains the cached component. We just return the cached component on the on this key and just cache to this type. We get the value on this key and cast to the type that we need. All right, let's just paste right over here. Go back to Unity, and now we need to fix these errors. Let me go to this player. Player's ground. Instead of player transition, will be to the player transition condition base. Alright, let's just override this. Setup condition will be right over here. Alright, and instead of getting player collider, just do the type. So it will be get entity component box collider. Alright, and then we do the same thing for all these states. Player idle state, it will instead of player state. It's correct. And here on the player idle state, just need to implement this base class and set right over here. Move. We don't need to get this. And here, get entity component, virtue body. And same thing here, animator. Alright. And I'll do this to all those states. So let's finish with this transition. And then ENT will compile the state machine code. So let's go back here on the settings, state machine states, and here we got the state definition. Now it will all make sense. So first we got the state base that it will be our idle state, and you can see that the validate functions that we set on the code is just for renaming this fields to not set as a elements. Then we got the transitions. Let's set the movement. The conditions will be we will go to the movement state if we are trying to move. And this will be our movement state base, and we will transition to the idle state if we are not moving. Okay, now let's create just the jump state that just go to idle if we are on ground. And we can also go from idle to jump if we are trying to jump and we are also on ground. And then this condition all needs to match. Okay, it's the same thing from the movement. From movement, we want to go to jump if we are trying to jump and we are on ground. And again, all conditions need to match. Now, if we remove the old state machine script, and I can also remove this player component reference and add the state machine. It will automatically add the entity components reference because of the required component. Now all we need to do is set the state machine states. That will be our player state machine states, right? And the state machine parameters, we can just create a new parameter, player state machine parameters. Let's set as it was, add right here. And if we press play, let's see if we get any error. No. Sometimes I'm jumping, I guess. Because the ground check, I also need to change that. So let's fix this. First, I need to adjust the box collider. Alright, guess that's a good value. You can see that sometimes we try to jump like this, and it goes back to the idle state, because when we check if we are overlapping any collider, we are still on ground. So when we set the state machine to the jump state, we actually need to remove the player from the ground. That way we can avoid this bug. Alright. Alright, so to solve the problem, all we need to do is remove the player from the ground once we enter the state. To do that, you can just create a new function, remove player from ground, but right here, and then just get the player's body position plus equals ground offset. Okay, just add a new field. For now, let's just skip the name. Later we can change. Okay. We don't want to set a big value for this, because if we just set to 1 right here, you can see that it looks like it teleports. We don't want that. Now let's just set a really small value. I guess this is good. Okay. Jumping. Alright. No more problems of we getting stuck on the ground once we jump. And that's good. Okay. So the player state machine is ready. Let me just move this component up. And I'll also remove this player put, but that's for the next part. Okay. Now let's just skip the entity components, rotation, and the state machine. And now it's more easy to add new states. So now we can also create a new state machine, player state machine, let's say without jump, for example. And I got this new reference. I forgot to check if it's new. Okay. But you can just copy this and then just actually duplicate this one and then just remove all the jump transitions. You also don't need the jump state, right? And then you just set right over here. And now you can't jump anymore. See? I'm pressing jump, but I can't jump. Yeah, that's that make our life easy. Okay. And the onValidate functions is just to rename these elements names. Okay. Guess this is much better of setting instead of setting the transitions right over here on the state, because now you can create any straight state transitions. You can make state machines without jump, for example, or any transition that you like, and all in one place. Okay, yeah, I guess that's it. Now we are ready to go to the letter state. But with these changes, it will be so much easier to do that. Alright, and I guess after the letter, I will change the way that we are dealing with the inputs, and then maybe uh, create the first zombies. I don't know, maybe we can, I'll plan that later, but this is the most, I guess this is the most important part because basically every entity needs to have its own state machine. That's why we just made this. Alright, so yeah, that's it. That's it for this part, and I see you in the next video. Bye.